Let's get into the problem. U is equal to 2x plus 2y. I'll differentiate with respect to x. I'll get a force minus 2 Newton, you keep it. Then I'll differentiate with respect to y. If you differentiate potential with respect to y, x component. If you differentiate with respect to y, y component. I think previous earlier classes we have discussed this one. Okay, like this is a force acting. Now, definitely this force is what? This force is a conservative force, no? Only I made things clear. O is related, how the force and potential are related, that strictly what is the condition for that force? That force must be conservative. So this should be minus 2i cap minus 2j cap. Okay, again, the particle is being moved on a circular path at a constant speed of 1 meter. Just try to make observation what I'm doing. Okay, this is a circular path and this is y, let it be x. So what should be the radius of this? Radius should be equal to 2 meter. So it is moving in circular path. And what is the particle? This is of mass m. It is moved in a circular path with a constant speed and v equal to how much? 1 meter per second. So directly straight away, what is the centripetal force acting on it? What is the centripetal force acting on it? There's a conservative. Let me write here. What is the centripetal force? I'm writing F centripetal. So according to the definition, what we know, centripetal force should be equal to m v square by r. So this should be equal to 0.1, 1 square, r is 2. So 0.
R is 4.
4, 4, no? R is 4. So this will be 0.025. So this is the Newton, this much of centripetal force. Okay, this just do make some observation. I'm just bringing even the external force into the picture. We are just confined earlier problems only to conservative force. Even external force also comes into picture here. Okay, this is about centripetal force. Now he's asking find the net external force other than the conservative force that must be acting on the particle when the particle is at 0,4. I think is it okay? This is what I'm picking up this one. The position also is shown. So this is the conservative centripetal force, what it is acting in. How to bring that external force? Look at conservative force, how it will act. Is it a constant or variable force?
Sir, it is
Conservative force.
minus j cap.
Yeah, in terms of vector, I'll do one thing. Next step, I'll write vector. Centripetal force equal to minus 0.025 Newton J cap. Now, what about this conservative force? Look at once, minus 2i cap, minus 2j cap. So how it will be directed? At all positions, for all the positions of the particle, it will be directed in one specific direction. No? So this conservative force, I'll show by minus I cap, minus j cap. What should be the orientation of this third quadrant? And it will make an angle 45 degrees. What are these red color dotted lines? The direction of conservative force that will be acting. And how much of angle it will make? It will make an angle 45 degrees. So shall we put this is no. Is it possible for this force, conservative force, to make the particle to move in circular path? If you can ask this question to yourself, problem is over. Not possible, no? So who can make the particle to move in circular path? Some radial force. Is it this conservative force? Is it a radial force? No. According to the given situation, this is a path of particle. So how to bring that external force? So now the particle is moving in circular path here. So the resultant of conservative force and external force will provide required centripetal force. This is the idea. So therefore I'll introduce like this. F external plus F conservative should be equal to F centripetal. We know conservative force and we know centripetal force. Substitute here to get F external. Getting this one. So can you solve this? Just as a mathematics. I just give idea.
So will we take F centripetal mv square by r, sir?
That is what, no? Centripetal force. Definition of it. Because it's saying it is moving under action of conservative force and external force. It is moving in circular path. So only conservative force is unable to provide. So some extra agent is brought here. The resultant of that will provide required centripetal force. That's what the condition given. So I'll bring external force by using this method. So take help of, already we know conservative force. Already we know this.
What's the work done by that force, sir? I mean, they asked us to work done, right?
Okay, wait. I'll explain. The first part is what I completed. Okay, this is about the work done by extra agent. So work done by extra agent should be equal to minus. So substitute this, you solve, you'll get the expression for work done by external agent. This is calculate the work done by external force in moving particle from 4, 0 to 0, 4. And what you are going to do for this. How to bring that? Let's do one thing. I'm testing small basics and nothing big. What is the speed of the particle? Constant, no? This speed is constant. And work done by action agent, Work-Engine theorem, work done by action agent should be equal to change in mechanical energy. And what is the change in mechanical energy? UF plus KF minus UI plus KI. What is kinetic energy? Kinetic energy is constant, no? Because it's a constant speed. So UF plus 0, UI plus 0. So therefore it is equal to UF minus UI. Do we know potential? Do we know potential energy of the system? As we know potential energy at both initial and final position. So what do you mean by initial? Initial is 4, 0. Here you calculate initial. Final is UF. Substitute that values and calculate it. So what is UI should be equal to? I'll come to the thing. So U equal to 2x plus 2y. What is ui is equal to 0, 4, 4, 0. So 2 into 4, 2 into 0, 8 joule. What is uf is equal to 2 into 0 plus 2 into 4, 8 joule. So 0.